Alright, so tomorrow's test will cover all of chapter 12. Okay? So that means that it's going to be arithmetic sums, it's going to be geometric sums, it's going to be infinite geometric sums. It is your job to figure out which is which, like on the formative that we took yesterday. I geared the formative yesterday as a great test practice where I didn't tell you what was what, you just had to go figure it out. Okay? So remember, if it's geometric, you're always multiplying to get the next term. If you multiply by something one time, that doesn't show a pattern. Make sure you check it on a second one, or a third one, or however many terms there are, check it all the way through. If it holds, yes, then it's geometric. Then you got an R value. If it doesn't hold, check arithmetic. It's going to be one of the two. Okay? It's going to be one of those two. All right? On top of that, we're going to have some, I know for sure that there's at least one make me a fraction kind of a deal one. Okay. Now, yesterday I accepted, or no, I gotta think now. Was it, did I have one on there? Fraction form? No, I didn't have one on there. Oh, it's on the homework. That was where I saw it. Okay. On the homework that's due today, there was one, the last one was like 130.130, 130, 130, 130, and so on and so forth. Okay? And I accepted, or I will accept 130 and then whatever the fraction is, 130 over 999. Okay? I'll accept that. Tomorrow, I want it in fraction form, which means improper fraction form, not mixed number form. Just so you know. Okay? Another hint about tomorrow, too. In the directions, it clearly states, give your rules, your arithmetic rules. Remember, we had 3 choices for arithmetic rules. We had basic, standard, and advanced. Okay? It says specifically in the rules, or in the directions, I should say, to give the advanced form of the rule. Okay? Which means do the distribution, combine like terms, and just write me out a rule nice and pretty. It makes it easier on me for correcting. So it's right there in the instructions for it. Okay? All right? I think there's anything else that I need to tell you about the test. I did put the formulas on there. So, yeah. Okay. All right. So, 0.74, 714, 714, 714, 714, 714, 714. So that is going to be 0.714 plus 0.000714 plus 0.0000714 plus, and so on and so forth. Yes, what's up?
Do we have to show that one? Or can we just go straight to the...
I would show it, but that's me. Because then I know, because then I can see what my pattern is. You know what I mean? But that's just me. You may be different. Okay? So that gives me a first term of 0.714. That gives me an R value of 0.001 or 1,000ths. Okay? It is an infinite geometric sum. The R value is in my acceptable range. So I can calculate it. So this is going to be, my first term is 0.714. My R value is 0.001. When I do that, I get 0.714. divided by 0.999, which simplifies as a fraction to 714 over 999, which is reducible because 714, 7 plus 1 is 8, plus 4 is 12, and 12 is divisible by 3. So 714 then is divisible by 3, and it actually ends up being 3 goes into 7 twice with a leftover of 1. 3 goes into 11 thrice with a leftover of 2. 3 goes into 24 8 times. So I get a fraction of 238 over 333. Yes? Okay. Applications today of infinite geometric sums. If we take a pendulum, okay, so I take a pendulum and I swing it back and forth, okay, it goes in a certain distance, right? And then it comes back and then it goes back a certain distance. And it's going to keep going like that forever and ever and ever and ever, right? Okay? Until it eventually will stop, right? Okay? So if I want to know the distance, the total distance that the end of the pendulum swings, okay? So I want to know the total distance that wrecking ball, whatever you want to call it, clock, pendulum on a clock, that swings, okay, total distance. So I'm going to read this problem. For a particular pendulum, each swing is 90% of the distance of the previous swing. If the first swing travels along an arc that is 20 inches, so it went from here to here, and that was 20 inches. What is the total distance that it swings? So that was going this way. Then it's going to come back now. But how far is it going to go coming back? Is it going to come all 20 inches back? Okay, nope, because a swing is one way, right? Okay, it's not like a bounce problem where it's going to bounce and come up and back down. So, how far does it come back? How much? 18 inches. Then it goes back. How far back does it go? 16.2 inches. How are you getting these numbers so quickly there, JK?
I do the number times 0.9.
Because that's our R value, right? Right? Yeah, that's our R value. Yes. Okay. So that tells me that I've got an R value here of 0.9. That tells me that I've got, oops, I put that in the wrong color, but that's okay. Oops. That tells me that I've got a first term of 20. Can I find now, is it an infinite sum? Yeah, because it's going to keep going on forever and ever and ever, right? Okay, until it eventually stops, right? Okay, technically, scientifically, okay, if I swung my keys like this, okay, and it keeps going and going and going and going, technically it's still moving. Scientifically, it is still going back and forth. We just can't see it in the naked eye. unless I put some extra resistance on it. Like if I squeeze up here at the axle part, okay, that's going to slow it down and stop it. But if I have zero resistance, okay, it will technically swing forever and ever and ever. Okay, but one, this room is not a vacuum, so we have air resistance and all that fun stuff. Okay, so the sum here is going to be 20 divided by 1 minus my R value, because it's an acceptable R value. It's in between -1 and +1. Yes? Okay. 1 minus 0.9. 0.1. 20 divided by 0.1. 200. So this pendulum travels a total of 200 inches in its swinging pattern, or in its swinging lifetime. Okay. Try that one. Gets you prepped for the test. Yeah, 8's good. All right, so reading this problem, it tells me that a company had a profit of $3,500,000 in its first year. Since then, the company's profit has decreased by 12% per year. If this trend continues, what is an upper limit on the total profit of the company can make over the course of its lifetime? Well, so it starts with, we got a first term of 3,500,000. Yes? Okay. We've got an R value of what? What would our R value be? No. No. 0.88.
Oh, okay, so we'll do it right. Why? I know. It's left over. So you do 1 minus.
Because it decreases by 12%, right? Which means that there's 88% left. So my R value is 0.88 to get the next term. Okay? That's an acceptable R for our range. So the sum is going to be 3,500,000. One more. Divided by 1 minus 0.88. Okay. Now, let's say, for instance, you didn't get that 0.88 number. Okay. What's a way that you could have figured out 0.88? What's a way that we could have figured out 0.88?
1 minus 0.12.
No, but you didn't know that. So if they made $3,500,000 in the first year, how much money did they make in the second year? How much? No. That gives me a negative number. So how did you get 3,080,000?
I did 3,500,000 times 0.88.
Okay. Or so if you did, but if you didn't know that, right? Okay. So if you did by 0.12, right?
Yeah.
Okay. So 3,500,000 times 0.12 gets me 420,000, right?
Oh.
But that's how much the profits decreased.
So then couldn't you just
It
subtract
says
it?
right here, Colin, decreased. So that's how much they went down. So 3,500,000 minus 420,000 gets me 3,008,000. Right? Nope. 380,000. I got the wrong zeros.
How did you say it? You did the first number times 0.12. Yes. And then you have to subtract that number from the original. I did it right. I just said that was 20 million instead of million. Yes, you should.
There, that one. Okay? And so on and so forth. Okay? So then we can find our R by taking that number and dividing it by 3,500,000. And we get 0.88. Okay? So, this gives me 3,500,000 divided by 0.12, which gives me a sum, an upper limit to it's the maximum that it could be of $29,166,666. Oops, that's a bad 6. $666.67. Okay. Golf ball is dropped from a height of 9 feet. After each bounce, it rebounds to 68% of the previous height. Find the total distance the ball will travel. Okay? So when a ball drops, it bounces, comes back up, back down, bounces, comes back up, back down, bounces, comes back up, and so on and so forth, right? Until it just rests. Okay? So, how many directions does the ball travel? 2. Which ways? Down and up. Okay, so which one do you want to do first? Down. Since it starts on high and it goes down. Okay? So if I do the downs, right? So my first, how far does it fall first? Falls how far? 9 feet. Then it does what? Rebounds how high? 6.12? Which means then it goes back down how far? 6.12. Then it comes back up. How high does it come back up?
4.16.
Which means it goes back down then, 4.16, right? And that trend continues. What's my first term over here? What's my R value over here? 0.68. Is that R value in an acceptable range to find the infinite sum? Yes, it is. Okay. So let's do that. So the sum is going to be 9 divided by 1 minus 0.68, which is 9 divided by 0.32, 9 divided by divided by 0.32 gets me 28.125. Agree with that? Okay. Which, Katie, I'm guessing when you were doing that problem, that's probably what something close to that is what you got. Right? So, you know what I mean, right? You got a number, and then you stop because you thought you were done, right?
Yeah.
Okay, all right? But now I've got my ups, because that's just the total of the down distance. Now I've got my up distance, which started at 6.12, and then went to 4.16, and then went so on and so forth. That gives me a first term of 6.12. That gives me an R value of what? Still, it's 0.68. So that one can be calculated then. And for that one, I get 19.125. So the total distance that the ball went is what?
47.25 feet.
How'd you get that?
I added the two sums together.
So it's the sum of the down plus the ups, right? Okay. You kind of got to use a little bit of logic in these infinite problems. Like a pendulum one, okay? On the pendulum one, okay? That's different than this because it's not bouncing and coming back up to a specific height. It's just free-flowing and air is taking effect on it. Okay? The ball bouncing, when it goes down, it bounces back up and it comes up to a certain height. Well, it's got to travel all the way back down because it's not going to bounce just on thin air. Okay? You know what I mean? It's not going to stop a foot off the ground and bounce there. It's got to hit something for it to bounce. Okay? So, you have the pink homework sheet due tomorrow. You have this homework due tomorrow. Okay? So, you should have plenty of things to do for the next 20 or so minutes. Okay?